Okay, great. So I'm going to talk about this paper that we presented at IMC last week that looks at the geographic properties of IP addresses contained within any single routing IP prefix in the routing table. So actually the motivation, I sort of thought about this, started to think about this problem several years ago when I saw some email going to the nanog list. It sort of, included some complaints about, having to advertise discontiguous prefixes and providing no opportunity for aggregation, and also various people saying that they advertised, they wanted to split a particular prefix into two contiguous blocks and advertise it from different locations. And part of the motivation for this study sort of came from that. I was thinking, like, well, how often is it the case really that these discontiguous prefixes are preventing aggregation where it should be happening, and the converse, how often is it the case that people are splitting their prefixes into multiple contiguous prefixes to get to better control, and how often is that potentially being messed up? Okay, so what we studied in this work was essentially those two problems, right? So the first thing we look at is we're studying the extent to which these IP prefixes are too coarse-grained, and by coarse-grained I mean two things really. One is that when we say a prefix is coarse-grained, we can say that it's the prefix is either being advertised from disjoint places in the geography, like two different pops, and that the IP prefix is either identical, as I've shown here, like the same /16 going out from two different locations. But we also consider cases, we study cases where the IP prefixes are actually contiguous as well. So we're going to study the extent to which that happens, and also the properties of how far spread out are any one of these single prefixes. When a single prefix is advertised from multiple locations, well, how far are those things spread out, and how many locations do they tend to contain? So I'll talk a little bit about that. The other question we consider is sort of the opposite question, which is, well, how often is it the case that we see two discontiguous prefixes being advertised from a single location in an AS? I'll talk a little bit about how we do that, because the notion of a prefix being at a location, really, that means basically we need to have some idea of, like, well, where are the hosts in that prefix? So in order to do that, we need to do some sampling. So let me talk about how we actually map these IP addresses or IP prefixes to a set of locations. That's really what we want to do, is for any one of these prefixes, we want to say, well, where are the hosts actually located behind within any one of these prefixes? And obviously that's a little bit of a tricky problem, and what ultimately we end up with is a set of locations for any one of these prefixes. But essentially, because we're sampling IP addresses inside that prefix, you can kind of think of this set of locations as a lower bound. So we might say the IP prefix contains hosts in n locations, when in fact the actual number of locations inside that prefix, maybe it's at least n, right? So how do we do this? Well, first off, we need just a working set of IP addresses, just to start with. So to get a good set, we get our initial set of IP addresses from two places. The first is there's this sort of public CDN project that was started by Mike Freedman at NYU called Coral CDN, and this thing gets upwards of several million unique client IP addresses every day in web requests. So we used that as sort of an initial set of client IP addresses to work with. That was convenient because in his system, he's actually already running trace routes back to the clients for various reasons. So we had some information about where those clients are coming from already. The other thing we do is to just get a better, a more broad coverage of the IP addresses in the routing tables. We basically take all the set of all the prefixes from route views, and then we sample those. We basically take, I think we took 4 IP addresses per prefix, regardless of the size of the prefix. So that was our initial set of IP addresses. Now, to get more, actually, what we did is we ran, as I mentioned, the Coral CDN already runs trace routes back to those client IPs. But also we ran trace routes to the IP addresses that we sampled out of route views, and that actually gave us more IP addresses to work with. So that's sort of how we built our initial sample of IP addresses. Okay, well, once we had that, of course, we sort of need to figure out, like, well, where are these hosts and routers and things? Where are they actually located? So to do that, we just use a heuristic. We just basically, a lot of these things, a lot of these IP addresses we can do a reverse DNS lookup on. And there's actually an existing tool as part of the script route project called UnDNS that basically has a lot of rules and rule sets for how various ISPs name their routers according to POPs, et cetera. So we're kind of assuming that those naming, those reverse DNS entries are actually correct. Which is one limitation, but that's sort of the best we can do, right? So from the DNS names, we can basically get a rough approximation of where that IP address might be sitting. In the cases where the clients were firewalled or whatnot, well, we use the trace routes to our advantage, right? Because we can just use what we end up doing is using the last hop on the trace route where we can actually probe and get a reverse DNS lookup. So once we have those, for every IP address we have a set of locations. Well, of course, we need to figure out like, well, what prefixes are we going to bin those IP addresses in? So to do that, we use the route views routing table, right? And we just do longest prefix match, right? So for every IP address that we've got in our working set, well, we can now just say, okay, that belongs to this prefix, and we know for each one of those IP addresses, of course, now which location it is in roughly. So now we can say, okay, for each one of these prefixes, we've got a set of locations. Now, as I mentioned, that set of locations is a lower bound, right? Because we're sampling IPs within any one of those prefixes, but it gives us, some approximation. So let's go back to the two problems. The first was, case we want to study, what we're calling coarse-grained prefixes, and let me just sort of describe to you sort of the scenario that we're interested in, and then I'll jump into the two questions. The first sort of scenario involves a situation where an autonomous system A might advertise a particular prefix and then a more specific out each of two links, for example, to try to control traffic coming in at location 1 and send some of that other, express that it wants some of that other traffic coming in from at location 2. Right. Of course, now as we know, B isn't really obligated to re-advertise those more specifics. So what might in fact happen is only the /16 gets re-advertised. Why is that problematic? Well, depending on I guess your philosophy, this may or may not be problematic, but we think it's a little at least worth studying, because it can cause this type of behavior to happen where ASA had actually wanted the traffic for that 10.1/17 coming in at location 1, and in fact, what it actually wanted to achieve isn't actually happening at all. And the other thing, just sort of another thing to think about, and why this might be a problem, is just to think about like why, what the job of a routing protocol really is, and what we really want the routing protocol to do is express reachability to a group of hosts, right? And now, if we've aggregated this information, yeah, we get nice scaling properties. On the other hand, if that link to 10, out of location 1 had failed, well, we're not going to get a BGP withdrawal for that /17 now, and we've got some worse correlation between the actual routing updates that are going around and the actual topology, right? So this is two sort of reasons why we might be worried about prefixes being too coarse-grained. The first question that we explored is to look at these these aggregated prefixes. Like, so for example, if we see like a 10.1/16 in route views, we can say, okay, well, how aggregated is that? How coarse is it? And how many hosts do we see contained in any one of those IP prefixes? So that's the first thing that we did, and these results actually, the general result isn't really surprising at all, right? This is a cumulative CDF, and that's probably a little bit difficult to read, but let me just sort of pull out a few data points and help you read that. Basically, what you can do is along the x-axis is maximum distance. So that's the maximum distance between any two locations in a set of IP addresses within any one of those IP prefixes. And then the y-axis is the CCDF. So what you can do is take any point on the x-axis and say, okay, well, now I look at the point on the y-axis and I can say, for example, from the blue line, well, 50% of the prefixes in that blue class, the /8 to /15 bin, span more, the maximum distance between any those locations span more than 100 miles. You can do the same type of exercise for the other plots. For example, about 10% of the prefixes in the 15 to /23 range spanned more than about 100 miles. Great. So what's kind of interesting in this curve actually is you know, the trend is kind of expected, right? But what turns out to be rather interesting is some of the case studies towards the tail, right? So for example, you know, we found one particular AS was like a backbone provider in Asia that had points of presence in various places in North America and Europe that had advertising certain /24s where we found IP addresses that were spread out more than 10,000 miles. And there were other sort of dial-ups and things like that that also had you know, things of similar sizes that were spread out, you know, 10 locations over several, you know, many thousands of miles. Now you might think, okay, well that's not surprising. Transit providers, of course, they're going to use these IP prefixes, and the you know, of course, you know, routers are going to be spread out all over the place. What's kind of surprising is we did find in a few cases, like we did the same study for stub ASs and found also that the tail is quite similar. So the details about that are in the paper. Now going back to this picture, another thing that we wanted to look at was, you know, let's look at these contiguous prefixes, the type of thing that A is advertising here, and we could say, well, how often is it the case that when we see two contiguous prefixes, you know, is it you know, how often is it the case that those contiguous prefixes are being advertised from different locations, right? So, you know, how often is it the case that people are trying to do what A might be doing? And when we looked at the pairs of contiguous prefixes that we saw in route views, it turns out about 25% of those contiguous prefix pairs contained hosts from different locations. So that's kind of interesting. It does suggest that people are trying to do this, you know, some sort of like locality, you know, controlling inbound traffic in this way. But it also suggests something for one of these reports that we see just about every week, right, where we see the CIDR report saying, oh, there are these contiguous prefixes with identical AS paths. Look how much we could decrease the routing table size if we just aggregated those. So what we did is we said, well, how, you know, let's sort of do the same study and let's see, you know, how true is it? Like if we assume that people are actually, you know, advertising these contiguous prefixes for a reason, well, how much could you reduce the routing table size now? So what we did is actually we did a CIDR report style study on our route views table, and if you just sort of apply the CIDR report rules, well, it's sort of like along the lines of what we see every week, right? You can sort of get about a 64% reduction in the number of prefixes in the routing table. That's great, but let's consider that maybe people are actually advertising these contiguous prefixes for a reason, and they may be, you know, actually being advertised from different locations, et cetera, et cetera. And if you do that and you sort of repeat the study, but apply these new rules that say, well, now we're only going to aggregate these contiguous prefixes if they have the same AS path and they only contain hosts from the same location. Well, then it so turns out that you only get about a 20% reduction. So, you know, depending on your, you know, I mean, depending on your philosophy, you know, whether you think that, you know, people should be allowed to do this or not, well, you know, it could be construed that the CIDR report's vastly overestimating, you know, how much the routing table size could be reduced by this type of aggregation. Okay, so let's sort of consider the opposite problem, right? Like we want to consider the case where, you know, ASA is advertising, you know, a whole bunch of discontiguous prefixes, but it really only appears to have hosts in one location or one POP for all of those sets of prefixes. Now, why is this a problem? Well, this goes back to the routing table size argument, right? It doesn't really make a whole lot of sense for ASA to be having to advertise all these different prefixes when, in fact, you know, if these things are in fact at the same location and, you know, traffic isn't coming in different ways and they're failing in the same fashion, then wouldn't it be nice if we could just sort of collapse that into one entry, or and that would also, in addition to reducing routing table size, reduce the amount of churn that we saw. So we wanted to see like how often, you know, when you look at discontiguous prefixes in the route views routing table, well, how often is it the case that those discontiguous prefixes only contain prefixes from a single location? It turns out actually that is you know, surprisingly common, right? So if you look at any pair of discontiguous prefixes in the route views table, about 70% of those are only being advertised or only containing hosts from a single location in AS. Now you kind of wonder why that's happening. Like, you know, why is it that these ASs are, you know, sort of advertising these discontiguous prefixes in that way? You might think it has to do with allocation, and that's exactly right. So basically, what seems to be happening is that these ASs are being allocated bits and pieces of address space, you know, that are not contiguous, and that wouldn't be surprising, right? You know, you'd think, well, of course, like an AS uses up its address space, well, it gets another allocation, happens to be not contiguous. big, no big surprise there. But actually, there's another surprise, right? Which is that a lot of these discontiguous prefix allocations are actually happening on the exact same day. So a particular AS may be getting discontiguous prefix allocations from Aaron on this, two different discontiguous allocations on the same day. And we found that for actually a significant fraction of the cases as well. So given that in our study we suggest we observe the prevalence of some of these problems, and given that coarse-grained prefixes can present problems for inbound traffic control, and fine-grained prefixes can inflate the routing table size, it seems like the thing that we want to think about is how can we fix this, right? And I think this is maybe why I got thrown in the research forum part of the talk, because I think this is rather speculative and probably bound to get some angry comments or questions at the end. But the only options I can think of how to fix this are actually rather painful, right? So, I mean, the first one is like, of course, well, you could renumber, but who wants to do that? The other is also rather grimly. Maybe we should. I mean, but maybe something that we should be thinking about as a research angle. And actually, that's something that I would like some feedback on. Is if we should we really be routing on IP prefixes? Is there a better way to be doing this that we could actually make scale? So, I mean, this is a really crazy idea, but let's try to let me throw out a straw man, and then maybe we can try to refine it. What you might initially think of doing is well, what if we just routed based on AS? Well, that seems ridiculous, right? Because various reasons, AS is having lots of pops and so forth, and wanting to have different destinations at different pops, blah blah blah. But maybe you could refine that, right? Like maybe we don't want to route on AS, we want to route on something that's more fine-grained. Well, could we divide our ASs into units or groups of nodes that we know fail in some atomic way, or that we know we want to control how traffic comes into the AS to this group of routers or this area of the AS in a different way than this other area? Well, can we divide it in that way? And maybe that's something to think about. So instead of just advertising discontiguous prefixes, well, maybe we advertise something that's more like a AS pop type of combination. Obviously, that's very speculative. I'm interested to hear what people have to think about that. And also, there's a really key open question there, which is what are we actually talking about? In terms of what should these units be? Now I threw out pop as an example, but maybe there's a different unit, and depending on what that unit is, of course, that's going to dictate how big the routing table is actually going to be, and whether we could actually make that scale, I think is a big open question. So just to sort of leave you with what I talked about, remind you some of the findings and open questions. We first sort of looked at how often these prefixes, identical prefixes or contiguous prefixes, are being advertised from different locations. We saw, obviously not surprisingly, that single prefixes can span very large distances, but also some of these contiguous prefixes often span that much. Based on that, you can sort of, if you apply different rules based on should these two contiguous prefixes be allocated or not, well, you can come to different conclusions about how much you can actually reduce the size of the routing table. Then we looked at sort of the extent to which prefixes may be too fine-grained, in the sense that an AS may be advertising discontiguous prefixes from a single location. And there, again, we found a surprisingly large amount of that occurring. So there, I think, that begs questions about routing granularity, and I don't have any good answers there, but I'd be interested to hear what you have to say. So thank you. Take some questions.
Hi, I'm Jeff Houston. I'm with APNIC.
Yep.
You mentioned the CIDR report, and that happens to be a report that I generate these
Sure.
days. And the algorithm that you pointed out was an algorithm that I certainly devised and used.
Right.
When I suggest what aggregation possibilities are out
Right.
there, I actually used 3 techniques, and
Okay.
all of which are imperfect.
Okay.
The first one is you try and do a precise match across the prepended AS path.
Right.
So what you're saying there is, if you're trying to traffic engineer, and I see 2 prefixes with the same traffic engineering going on, then maybe they're candidates for being merged. The next one is I strip out
Sure.
I strip out all the prepending and say, well, the path's the same. From where I am looking, they look the same.
Mm-hmm.
And the third one is really, really brutal.
Okay.
You're an origin. You're advertising multiple prefixes. Merge them. I don't care about traffic engineering. So there are 3 numbers coming out.
Okay. So I guess I'm suggesting like
all of which are imperfect.
Right.
And what I was really wanting to do was to figure out, can I merge them with traffic engineering? So what I was really wanting to do was to find out if from any vantage point you always saw the same path.
Okay.
That has nothing to do with geography. Because realistically, geography doesn't come into routing. What's going on here is I'm trying to understand if people are simply splashing out more specifics because they know no better.
Oh, I understand that, yes.
Or because they're splashing out more specifics that I can't see because of distance vector, route merging. And I can't see the fact that they're going elsewhere. So if you really want a research problem around this, the issue is, can you, from your vantage point, find out if more specifics are somewhere else with different paths? And that would say, well, there are localized regions why I'm actually seeing the more specifics elsewhere.
Right.
And as for the routing comments, I think you're going to...
Well,
I'll leave that to you.
That point is well taken. I guess the rule that we applied there is, I guess, what we thought is, if you have an identical AS path and an identical location from which you're advertising this prefix, then you know no better. But if you have different locations for these contiguous prefixes, is there not a good reason for doing so?
Oddly enough, most of the reasons for traffic engineering are very, very local.
Okay.
And the real issue is that what we'd like to happen is that the more specifics vaporize when my ability to pay for you to carry them vaporizes as well.
Okay. Yep.
Why should I pay for your traffic engineering? Not you particularly, of course, Nick. There's actually a knob request filed at Cisco from a number of people to give me a knob to say, if you see a bunch of prefixes that are aggregatable, that are covered prefixes. In other words, you see something that is a fragment of what is already announced, the longer prefix that is already announced that I've got, that's got, and the knob is gradated, has the same AS path, has the same origin AS, etc., discard it. The significant portion of the table, the rib I'm carrying today, is a bunch of /24s chopped up from much shorter prefixes by people who think they're protecting their networks against other people announcing their prefixes by announcing all the possible more specifics. I don't want to pay for that. Okay.
Now, what if? Can I ask you a question? Now, what if someone were to pay you to do that?
Well,
how would you feel about that?
Sean's not here, but he's here in spirit.
Right. Yeah. I mean, I've read his mails to the list as well, and I had a similar idea. I noticed he suggested this like 10 years ago.
I am a fan of Sean Doran.
Yeah.
so if somebody wants to pay me, I'm not here because of the religion, the food, or the sex.
Right.
No, I'm not. You're not paying me. Well, if somebody paid me to carry the
ideally, it'd be nice to figure out a situation where you would carry them, and I could do what I want at the stub, but you're happy, like you're paid somehow.
Right.
Yeah.
Now, this gets back to my comment yesterday about the lack of a routing economy. If you're my customer, I'll carry it. You're paying me. But Randy's my peer. Are you paying me? That's fine. But what about when I pass those across to Randy?
I understand, yes.
And in fact, I did filter him as a peer.
So the issue goes, how can you devise a routing economy where you can pay globally?
Exactly.
And that has been on the table now for about 10 years.
And why hasn't it gone through? I'm curious.
Because no one can figure out who gets the money.
Okay.
I do.
Oh, sorry. People disagree that Randy should get all the money. And that's a legitimate disagreement, I would have thought.
But in fact, I have filtered Jeff's traffic engineering historically, A. B is when I wear a filter Nazi hat, I do accept what my customer announces. They are paying me to do that.
Absolutely, yeah.
Right? But I don't have to listen to it from him.
Absolutely. Oh, hey Randy, what did you think about the routing granularity question? I was just curious.
Speak for yourself, sir.
What do you think about routing? So actually, yeah, I should ask you, Jeff, because you suggested 4-byte AS numbers, right? So what if 4 bytes were enough to hold every,
Again, this gets
every
back
sort-
into some well-trodden paths about how else you could route. And perhaps the best research work to point you at is work that was done at CADA by some research folk with Casey.
the policy atoms? Work?
Yeah.
Okay.
In and of itself, the inter-AS routing domain is really small. 25,000 ASs, the total number of discrete AS paths up around 50, 60,000, doesn't grow anywhere near the number of prefixes, could work well. But how do you flood the association of prefixes with that topology? And then you get into the big problem that Atoms gets into of trying to do the association of the coarse to the fine, and then you get back into the same problem as you're in today.
Yeah.
So by all means explore the space, but by all means also understand where we've been already, and we've covered
Absolutely.
a lot of these paths already. New ideas in routing are amazingly difficult to find. And the more paths we explore,
Right.
the more we think we've covered most of the visible corners. So now it's a case that you've got to be pretty deep in terms of trying to find areas that might give us traction. The other way of doing it is to try and limit the noise. And that's the other way of trying to actually understand how can I limit fine-grained prefixes and stop them going global. Because I don't need a new routing system if I can limit the extent of fine-grained noise. Now, right now, as operators, we clutch on what we know. We prefer not to put in a new routing system every 2 years or even every 10 years. We'd prefer to find ways to limit that. So if you look at the IETF, there's a TTL knob flying around, that you might do a TTL of 2, which is slightly greater than no export. There's another one flying around called no peer, trying to describe when that prefix should be vaporized because my money has disappeared and I'm not paying to have it held anymore. And I suspect in the operator community, we're more interested in pragmatic knobs on technology we know than trying to say, oh, the whole thing's stuffed, let's try and do something far more complicated that we really don't understand. Thank you.
I'm going to do something far more simple.
And could you please, Eddie Drager, could you please go back to the CIDR slide? There's one thing I want to disagree with there.
Sorry. Where are we? There. Let's look at that.
As far as the close geographically requirement,
Yep.
that holds for one's upstream. But let's say that I advertise 10.0 in LA and 10.1 in New York, then and I'll advertise them to level 3, then the rest of the world, except for Cogent, will see the aggregate if I also advertise the aggregate, because the more specifics don't need to be heard by every other provider, where for them it's just a matter of hand it off to level 3. So really the geographically close requirement, it does hold for one's upstream, but not for the upstream's peers or fellow upstreams.
Well, I mean, it tends to hold as long as you're guaranteed to go through some AS that has the more specifics, then you're fine, right? Like if I aggregate but I never pass one of those people who's holding all the more specifics, then I'm in trouble still.
And, well, that gets into your using it for TE, but as far as for geographic requirement, there again, you only need it to your upstream, not the rest of the world, not the global routing table. For the global routing table, just advertise the aggregate and let your upstream handle the specifics and not export them to any peers.
I think so a lot of this is exacerbated by the view that RouteView has is often the internal view. And a bunch of those prefixes really don't make it very far. There's also, there aren't too many of them, but a bunch of the old networks took a 16 and smeared it across all their /30s for, and loopbacks for their entire global network.
Definitely, yeah. That
I would, of
that
course,
could
never have
definitely be, yes.
participated in anything like that. And
Actually, one thing we might want to do is actually repeat this same experiment, but only do it for stub ASs, whatever that means.
yeah, or actually we can enumerate those. We just know them: 129, 50, 140. But I don't. Another little quibble is I don't think the registries really, by the way, allocate disjoint stuff on the same day to the same. I think that was something that's actually.
Depends on how you define disjoint.
Try Mike.
Scott with Internet. Aaron gave us basically a block and a half. They gave us I think it was a 16 and a 17 or something like that. They're adjacent, but they're not aggregatable.
Folks, I need to cut this off. We're running like 20 minutes behind schedule now, so thanks for your questions, and thank you, Nick.